Okay, so let's talk about percent composition. What percent composition is, it's basically the percent by mass element in a compound. Okay, so for example, what percent of CO2 is carbon? Okay, that's the type of question. Um, the way you find that is you have the mass of the element that you're looking for divided by the mass of the compound. Okay, and then because it's a percent, you're going to multiply it by 100. All right, so this is your equation that you're working with every single time. All right, with percent composition, it doesn't really matter how I ask the question because there are a couple of different ways I could ask it, but it doesn't really matter what how it's asked. That's the equation you're working with. Okay, so let's do a couple of examples. So find the percent composition of copper to bromide. Now, I didn't specify what element I wanted you to find. So when that's the case, you're looking for both elements. Okay, what percentage is each one of these? All right, so the first step, you have to find the molar mass. Okay, so find molar mass. Okay, so copper, there's one copper, and it is 63.55 grams per mole. And then bromine, there's two of them, and each one is 79.90 grams per mole. So we have 63.55, and then 2 times 79.9 is going to give us 159.80. Add those together, you get 223.35 grams. Okay, so that is the mass of the compound. All right, and then we're just going to take each one of these individually and divide them by the mass of the compound. So for copper, all right, we have 63.55 grams of copper divided by 223.35 grams of compound times 100. That gives you 28.45%. Now, if you are a stickler and you want to make sure that you're doing this absolutely correctly, you could do the math for the next one, okay? And we can go ahead and do that real quick. So bromine is going to give us 159.8 and divided that by 223.35 grams, multiply it by 100, and you get your answer of 71.55%. Okay, but that wasn't necessarily, super important to do because we only have two elements. Okay, and if 100% is our total, all right, and copper equals 28.45%, you take 100 minus 28.45 and get 71.55 for the remaining element. Okay, so there's two ways you could do that one. But this one will always, this first way that I did it will always give you the right answer. Because if you messed up in the first one and you didn't mess up in the second one, you could see that it probably doesn't add up to 100 and you may have made an error somewhere. Okay? So let's do another one. By mass of a compound that is 31.3 grams of sodium and 42.6 grams of chlorine. Okay, now I've told you how much of each element there are. Okay, so in this case, we don't have to look at the periodic table. We know the 31.3 grams is sodium, okay? And we know that 42.6 grams is chlorine. So all we have to do is add those together. So we have 73.9 grams total for our compound, okay? And to find each one, we have 31.3, this is for sodium, divided by the 73.9 times 100. Okay, and we get 42.35 sodium. And for chlorine, 42.6 grams divided by 73.9 grams times 100, and that gives us 57.65% chlorine. Okay, so those are your two percentages. So in this case, you did not have to do anything with your periodic table because I gave you how much of each element there was in the compound. Okay. So let's do another one. I could just say find the percent of oxygen in NaOH. Okay. So now we're only looking for oxygen, but we still don't have a mass, so we have to find the mass of the whole thing. So sodium, oxygen, and hydrogen. All right, we have one sodium. Gives us 22.90 grams, or sorry, 0.99 grams. It's always important to make sure that you're writing this down correctly. Oxygen, we have one that is worth 16.00 grams, and then hydrogen, we have one that is worth 1.01 grams. Okay, because they're all ones, you just add them all up, and you end up with 40 grams as a total. Okay, so that's going to be our total mass of the compound, and we're only looking for oxygen. So we're going to take 16.00 divided by 40.00, 100, and we get 40%. So sodium hydroxide, which is what this is 40% oxygen by mass. Okay, let's do one more. Okay, so we're going to find the composition of, let's say, ammonium sulfide. Okay, so first we have to find the mass of the compound. Okay, so we have nitrogen, we have hydrogen, and we have sulfur. Okay, so we have two nitrogens, and each nitrogen is going to give us 14.01 grams. We have 8, 2 times 4, okay, 2 times 4, so we have 8 hydrogens. So each one gives us 1.01 grams from the periodic table. And then sulfur, we only have one sulfur, and that gives us 32.07 grams. Okay, so we multiply those across, we get 28.02, 8.08, and 32.07. And we get 68.17 grams, okay, as a total. So for nitrogen, we have 28.02 divided by 68.17 times 100. For hydrogen, we have 8.08 divided by 68.17 times 100. And then for sulfur, we have 32.07 grams divided by 68.17 times 100. Okay? When we do this math, we end up with, for nitrogen, we have 41.1% nitrogen. For hydrogen, we have 11.9%. And then we have 47.0% sulfur. So even though we only have one sulfur atom, because its mass is so much greater than everything else that it's attached to, it still has the majority of the mass of the actual compound. Okay, so that is percent composition. It can be asked either as an entire molecule. It can be, I can give you the mass of each individual one, just like we did here. Okay, or I can just say, give me, one element of the compound. Okay,